HIW is fortunate that we're celebrating our 14th anniversary with many more success stories added into our legacy. I would like to express my gratitude to my team, remarkable effort, standing with me on being the phone.
I'm very glad that HIW is growing into larger organization. Glad that larger organization
Sorry guys, there was a network glitch with us. Sorry that the video was interrupted in between. Hello guys, welcome to HIW's third day session on VLSI, where we are talking about 5-day masterclass of VLSI. In the previous two sessions, we have discussed about what is VLSI, and then we've also understood what is the difference between VLSI and embedded in yesterday's session, where we've understood how to become the industry ready with respect to VLSI and the training. In today's session, we're going to talk about the coding about VLSI and also certain tools that are being used on VLSI. Welcome, Prithvi. I think you can go on with. Thank you.
Yeah, thanks, Bhavya. Hello, all. Good evening, and welcome you all to the day 3 of Silicon Symphony. So, as I have discussed yesterday, we will be seeing or we will be writing, the basic code in Verilog. Okay. So, shall we wait for a couple of minutes so that the count might increase? As of now, I could see only near 150 have joined.
Prithvi, I think we can start on no problem. People are joining. No issues.
Okay. Okay. Fine. Yeah, I guess the screen is visible, right? Is the screen visible? Yeah, can anyone confirm the screen is visible?
Yes, Prithvi, your screen is visible. Can you please make it full screen?
Yeah, sure. Give me a minute.
Now we can see all the tabs. Yeah.
Yeah, okay, fine. Great. Okay. Okay. So, guys, as discussed yesterday, today we will be writing basic code in Verilog. Okay, let us start with coding of Verilog. So as I have discussed yesterday or from the past two sessions, what is Verilog? Verilog is a HDL. HDL stands for hardware description language. It's a language which describes certain hardware, right? So let us see on like what are the different tools we have in semiconductor industry, and how can we access them for free, or if so, what are the means of accessing them. And if you want to write Verilog code, or whether it is SV or UVM, how to do all these things. So our today's session will be focusing on these things. Okay, so in order to write the code, in order to start with coding part, there are many tools, but the one free tool which everyone can use is the EDA playground. That's what you can see here. Okay, it's edaplayground.com. Okay, basically there are many EDA tools available in the market or in the industry. Basically EDA stands for electronic design automation. Okay, so how to access this, or what you need to do, just go to Google and type edaplayground.com. Okay, then or else, okay, let me, it is directly opening the website, right? So let us try searching for it here. Okay, you just need to enter EDA playground. Then you choose one website that is something like this, edaplayground.com. Okay, get in there and it will ask you to log in. Okay, see, here there are two things with respect to the logging. One is, see, if at all you want to access all the tools, okay, if at all you want to access all the tools that were there, what you need is, you need some official mail ID with you. Okay, you need some official mail ID. So I mean, for example, if you see here, I have my some by official mail ID, I mean to say it is some mail ID with some domain. It is not like at the rate gmail.com or at hotmail.com. That doesn't work. Okay, apart from that, official mail ID means probably your college might be giving you some mail IDs, or for example, at nitdelhi.ac.in, or I have my company's mail ID like at valsaksemi.com or something like that. Those are called what? They're the official mail IDs. So you might be asking me like, what if we don't have official mail IDs? How can we have official mail IDs being a student? Some colleges will provide, but no problem if you do not have official mail ID. There is a way of accessing these tools online even without having official mail ID. How is that, or how can we do that? We will be discussing that. Okay, so as of now, as I have this official mail ID, so what you need to do is initially go with this EDA playground. Okay, open edaplayground.com and you will see something like this. Okay, so what you have to do, you have to register for a full account. If at all you are having the official mail ID, then a window will pop up where it will be asking you to log in. So you are supposed to furnish some information, and you are supposed to register for a full account. Okay, it will ask you to register for full account. Okay, you have to do some full account registration, then you will be entitled to use all the features of this EDA playground with the help of this official mail ID. So as I already have this, so what I'm doing is I'm directly logging in. I will tell you what if you don't have the official mail ID. So I'm logging in. Okay, so I have logged into this. The moment I have logged in, a screen appeared with two windows in it. Okay, as you can see here, this is the first window and this is the second window. There are two windows, and first window is telling that code your design here, and second window is telling that code your test bench here. Okay, so what is this design, what is this test bench, all these things we'll be discussing in a couple of minutes of time. Okay, so first let us outrightly start writing some basic code, then you will understand on what I am talking about. Okay, so see here, basically I will tell you the structure or architecture of coding once writing a sample code for you. So first let us write some sample code on Verilog, and then we will proceed with our discussion. Okay, so basically Verilog is a module based language. So whatever the thing that you write, that should start with a module and it should end with end module. Okay, it should start with a module and it should end with a end module. So if there is a module, the module should be given some name. For example, here what I will be writing is module first underscore program, something like this. I have written a module name. Okay, and then if it's a module, then it should have end module. Okay, so whatever the thing that you're writing here, that should be within your module and end module. Okay, is the font okay to you guys? Are you all able to see the font? Can you respond through chat? Okay, fine, that's great. Thanks for the response. Yeah, so whatever the thing that you're going to write, it should be between module and end module, and your module should be having some name. For example, here the name I gave is first program. Okay, then here this dollar display is nothing but it is similar to your printf statement in C language. So hello silicon, like Symphony day 3, some string I am writing here. That's it, done. Okay, I have written some basic code here. What I have initially done, a module, end module. I have named my module, and I have taken some initial block. I will tell you what is this initial and all. Don't panic as of now. So I have taken an initial block, and I have just displayed some basic string. Hello Silicon Symphony day 3. Now how to run this? That's the basic question, right? So here you see there is a save button here. Yeah, and there is one more thing here. What you could observe is a star mark. Okay, save button followed by a star mark. Now see here, I'm clicking on save. So what is it asking me? Read this. What is it asking me? Please select a valid tool. It is asking me to select a valid tool or simulator. So what I have to do? I have to tell this EDA tool that what is the tool I want to use, or what is the simulator on which I want to perform this program. Okay, let us do that. And where is that? So see here. Here you could see something like this. No, here there is tools and simulators, languages and libraries, and one more tab is examples. Correct. So let us click on tools and simulators. On these tools and simulators, there is an option called select. So you select it. The moment you have selected it, a window will pop up with some tools like this. What are they? See here. Okay. See here, the tools are Aldeck Rivera Pro, Cadence Exilium, or few people will also call as Cadence Xilium, Siemens Questa, Synopsys VCS. What are all these things? These are simulators. Okay, these are the commercial simulators. In fact, these are the tools that industry will use in real time. Okay, whatever the project you work on, so it will be any one of these tools that you are working in industry. What are they? Aldeck Rivera Pro, Cadence Xilium or Cadence Exilium, and Siemens Questa, Synopsys VCS. So these are the commercial simulators. These are the paid simulators. Okay. So what we have to do as of now, we are only running the simulations. So we have to select any one of the simulation. For example, for time being, what I am selecting is Siemens Questa. I have selected this simulator. Okay, done. Now what I have to do? I have to save this. Can you see the save button here? Now I have to save this code. The moment I clicked on save, what happened? The code is saved, and what is the thing you have observed here? The star mark got disappeared, right? Previously I had a star mark, now it disappeared. So what does this star mark basically signify? See here, now what I am doing is I am trying to edit my code. See here, I have simply entered a new line. Okay, previously, okay, see now how many lines of code is here? There is something around 8 lines of code is here. Now I deliberately included 2 more new lines with nothing in them, but I have entered new lines. So then what happened here? You are seeing the star mark again. So basically what does this star mark indicate? It indicates that there is some unsaved code. Okay, there is a code in your tabs which is not saved. So the star mark is indicating that there is some unsaved code. So what you need to do? Now I am clicking save. The moment I clicked on save, what happened? star mark disappeared. It means that whatever the thing that you have in your tabs is saved. Now what I have to do? Now I have to run this code. Okay. Now I have to run this code. Go to this run tab and just click on this. Your code will be running now. Your code will be running and you will see some output. So what is the thing I have given here? Hello Silicon Symphony day 3. Okay, that's what we can see here. Hello Silicon Symphony day 3. So I got some output here. So this is a basic starting point of a code. Okay, this is a basic code. Now see here, how can we optimize this code? This is a basic code. Okay, fine, that is fine. Okay, so now what we will be doing is we will be writing some other code for an AND gate. Okay, I hope everyone know the functionality of AND gate, but for time being let me discuss it in brief. What does AND gate will do? It will be having some two inputs A, B and one output Y. So output will vary depending upon the inputs of A, B. So 0 0 0 1 1 0 1 1. Okay, so if it is 0 0, output is 0 0 0, and if it is 1 1, output is 1. Okay, this simple code. I mean, this is a simple truth table or the truth table of AND gate. And what is its characteristic equation? Y equal to A and B. Right? This is the characteristic equation, or this is the equation you will end up when you solve the corresponding two variable K-map. If at all you solve the two variable K-map, this is the equation that you are going to get. Right? So now let us quickly write code for our basic AND gate. And yeah, before writing that, I would like to show you one thing here. So see here, what is this tab displaying? Telling me code your design here. And what is it telling? Code your test bench here. So what is design and what is test bench? What is design? What is test bench? The basic question, right? What is design? What is test bench? See, in our yesterday and day before yesterday's discussion, what did we do initially? We initially want to design a half adder or a full adder we want to design. So for that purpose, what we did initially, we came across what is the hardware required for it. That is its equivalent digital diagram. And then what did we do? We have represented this by using some HDL language. So we have written a code for it. Okay, we have written a code. That means this code is nothing but our RTL design. The code is nothing but what? This is our RTL design. Okay, code is written, fine. Then what we need to do? Once after writing the code, what we need to do? We need to verify, right? We need to verify whether our design is working correctly or not. So we need to verify its functionality. In order to verify the functionality, what we have to do? We need to test our DUT, or we need to test our design. Okay, what we have to do? We need to test whatever the RTL logic that we have written. We need to test that. So we need help of something known as a test bench. We need help of something known as test bench in order to verify whether our design is correct or not. Okay, so what is the significance of test bench, guys? The significance of test bench is that in order to verify the functionality or the correctness of our design, whatever the RTL design that we have written, in order to verify its proper functionality, what we need something to test it. Okay, whatever the thing we are using to test that particular RTL is known as test bench. Basically, your test bench is having some test cases into it. Okay, basically your test bench is having what? It will have few basic test cases into it. Okay, so now based upon this discussion, if at all I ask you to write code for some basic AND gate. Okay, so how many codes you are supposed to write? How many codes will you be writing? See, you have to write a code for its design. Yeah, you have to write code for the design, and then you have to write one more code. Why is that second code required? The one more code is nothing but test bench coding. What you have to do? You have to do one more code, that is test bench coding. So any design should have two codes. One is the first code is the actual design, this is where your core logic lies. Okay, this is the point where your actual or core logic of your design lies. In order to verify this design, you have to write one more code. What is that? That is your test bench. Okay, the name itself is telling why is it created. It is specifically created to test. To test what? To test your RTL logic or to test your code, design code. Okay, now let us quickly start writing our code. Okay, so our design should start with what? Or any code in Verilog should start with what? It should start with a module, and we should name our module and underscore gate, and then here our AND gate will be requiring how many inputs? It requires two inputs, a comma b. And how many outputs does it require? It requires one output, that is y. Simple. If it is a module, it should also have end module, because module is the basic entity in your Verilog coding. So if there is a module, there should be end module, and if there is a module, there should be a name to that module. And what is the name we have given here? That is and underscore get. So you might be asking me like, why underscore? Why can't I give and specifically? See, in Verilog, and is a keyword. So you are not supposed to use your keywords as name of your module. Okay, please remember, you are not supposed to give keywords as name of your module. And is a keyword. That is why you could see the change of color here. The moment I say and underscore something get, it is changed, the color is changed. So you are not supposed to use any keywords or any keywords as your name of the module, and your module name should not start with numbers. Okay, it should not start with numbers or special characters. You have to make sure of these things while naming your module. Okay, fine. So this is my AND gate and a b y. And now what I have done, I have named my module and underscore gate, and I have something within a braces. What is this? Whatever the thing that you are writing within this, okay, they are actually the port list. So whatever you are writing within the braces, they are known as what? It is known as the port list. How many ports does your basic AND gate requires? It requires 3 ports. Okay, your AND gate requires 3 ports. Among them, 2 are the input ports and 1 is the output port. So what are your input ports? A comma b are your input ports, and what is your output port here? Y. Y is your output port. Okay, so 2 input ports, 1 output port. So as it is an AND gate, it requires totally 3 ports. So that is the reason. What did I do? I have declared all my ports here, A, B, Y. As of now, do I know its direction here with respect to A comma B comma Y? Here I have not mentioned like among them which two are inputs and which one is an output. I am yet to declare that. So now what is the next step we have to do? The next step we have to do is declare the direction. Okay, what I have to do? I have to declare its direction. So among these three, A comma B comma Y, my A comma B are inputs. Okay, my A comma B are inputs, and my Y is the output. So in these two lines, line number 3 and 4, what did I do? I have declared the direction. Like among these A, B, Y, how many of them are inputs and how many of them are outputs? Okay, so basically I told this that there are 3 ports, and I have mentioned that within the sensitivity list they are A comma B comma Y, and then I have given the direction to them, input output. So far so good, everything is clear, right? So far. Now what I will do is I will use a keyword known as assign. What is this assign? As of now you don't know, don't panic, but you just presume that you already know it, and I am using a keyword assign. Now what I am doing is assign output Y equals to A and B. That's it. Okay, assign Y equal to A and B. So why did I write Y equal to A and B? Because A and B is the characteristic equation for what? For your AND gate, right? So that is the reason I have used it here. A and B is the characteristic equation of AND gate. Okay, so now whatever the thing we have written here, this is a basic code of a AND gate. Okay, here we have written RTL code for basic AND gate, as simple as that. Okay, now our design is ready. Now whatever the thing I have written, I will be calling this as my design. So this is my design. Okay, designing is done. And is it alone enough for me to tell that its functionality is correct? No, no. In order to verify its functionality, what I have to do? I have to write one test bench for it. Okay, I have to write one more one more program. Basically, that code is for test bench. Okay, so now let us go with the code of test bench. Okay, if you feel like at any point of time you're not following, please feel free to interrupt me or type in the chat box so that my team will let me know, and I'll be explaining you that particular part, or we will be going through it again once we are done with the basic coding. Okay, so whatever the code it is, whether it is our design or test bench, it should start with module and it should end with end module. This is quite basic. And if it is a module, it should have some name, right? So what I will be writing here, and underscore tb. Okay, and underscore tb. Kindly remember that test bench will not be having any port list. Here only the DUT will be having ports. Test bench will not be having any ports. Now here what we need to do is, this is a little bit tricky actually. You need to remember this. See here I have two inputs and outputs, right? So while writing your test bench, what you have to do is you have to declare your inputs as registers. Okay, you have to declare your inputs as reg a comma b. You have to declare your inputs as what? Reg. And you have to declare your output as what? Wire. You have to declare your output as wire. Why should you declare these things as reg and wire? You know, it is, you are premature to understand that. Okay, as of now, but you just go with the notion that all your inputs should be declared as reg and all your output should be declared as wire. Okay, you just go with this notion as of now. Even though I tell you the explanation, you will not be able to digest it at this point of time. Okay, so now what I will be doing, I will declare my inputs as what? Reg a comma b. Okay, reg a comma b. And what is my output here? Y is my output. So I will be declaring my output as what? Wire. Okay, so now the basic ports I have declared even in the test bench. Fine. Now what I have to do? Yeah, what I have to do? See here. Now I have to do something known as module instantiation. I have to do something known as module instantiation. How to do module instantiation? Simple. Copy this guy from here as it is. Okay, go to the, copy the name of the module as it is, come here and paste it here. Okay, the only thing that you need to do here is you need to give some name to this. Okay, and this particular step is known as what? Module instantiation. Okay, this is known as what? Module instantiation. Okay, and what is this DUT here? What is this DUT here? Here, whatever the thing I have written like DUT is known as what? Module instance name. This is what? This is module instance name. Okay, whatever the thing I have written here, that is DUT, it is known as what? Module instance name. So what does this DUT basically stand for? This DUT stands for design under test. Okay, DUT basically stands for design under test, or few people will also name it as UUT. UUT stands for unit under test. Okay, UUT stands for unit under test. Or see, you can name it anything. Okay, not just DUT or UUT. For example, I want to name it as A1. No problem, nothing wrong. You can name anything. Okay, you can name anything here. So in this case, what is this A1 here? This A1 is your instance name. A1 is the module instance name. Okay, now in this line number 6, what did I do? I have instantiated my DUT into the test bench. And how to do that instantiation? You need not to do anything. Just copy the name of the module from your design as it is, paste it here, but only thing you need to do is you need to give it some instance name. That name can be anything like A1, A2, A3, DUT, UUT, whatever the thing you want, you can give. After this, what we need to do? See, how can you tell that your AND gate is working perfectly? Based on what? For example, I have input AB I have output y. So how can I tell that my AND gate is working perfectly? Based on what can I say my AND gate is working perfectly? For example, let us assume, okay, so I have given input as 1 0 and I got the output as 0, and I have given input as 1 1 and I got the output as 1. So depending upon these two things, can I say that my DUT is working perfectly? Is it alone enough? No, it is not, because maybe if I give input as 0 1, I might be getting an output 1. I might be getting, or I might not be getting. So if I get output as 1, what does it mean? It means it is wrong. The functionality of the design is wrong. It means that there is a bug in the design. So in order to make sure that my design is working properly, what we need to do? We need to give all the possible inputs to our DUT. So for AND gate, how many possible inputs will be there? There will be 4 possible inputs, like 0 0 0 1 1 0 1 1. So these are the 4 different possible input combinations that are possible. So what we need to do? We need to drive these inputs from our test bench to our DUT. What we need to do? We have to drive our inputs. We have to drive these inputs from the test bench to the DUT. Okay. Now let us do that. Okay. So in order to do that, what we need is we have to take one initial block. What is this initial what? So this initial block should be between begin and end. Now what I will be doing is I will be giving something like a equal to 1 tick b 0 and b equal to 1 tick b 0. Okay, and then what I will be doing is okay. So after this, I'll give some delay of 5 time units. Then what are the possible input stimulus for us here? It is 0 0 0 1 1 0 1 1. So AB should have all these 4 different possible values, right? So now see, initially I have given 0 0, and then what I will be giving? I have to give 0 1. So here if you see, my value of A is what? I will tell you, like, okay, let me tell you here itself. So what is the meaning of A equal to 1 tick B 0? What does it mean? It means that I want to give a value of 0 to the variable A, and this 0 is in binary format, and this 0 is in binary format, and it is of single bit value. Okay, I repeat, the moment I wrote like this, A equal to 1 tick B 0, by this what do I mean is I am giving a value of 0 to the variable A, and this 0 is in binary form, and this is of how many bits? It is of 1 bit. So what if I want to represent some 2-bit value? It means that you have to declare it something like this. For example, something like x equals to 2 tick b 1 0. What does it mean? It means that value of x is how much here? It is 1 0, and it is represented in what format? It is represented in binary format, and it is of how many bit value? It is of 2-bit value. Okay, so that is what is the meaning of this particular line. Here what did I write? I write A equal to 1 tick B 0. It means that value of A is 0, and it is represented in binary, and it is of single bit. Okay, fine. Hope it's clear. Yeah. So I have erased this thing. I'm sorry for that. So 0 0 0 1 1 0 1 1, and possible output is something like this, right? So now initially what did I give here? I gave 0 0, and then what did I give? I have to give what? 0 1. So see here, value of A is 0, and then value of B is 1. After that, again what I will do is I will wait for 5 more time units, and then 0 0 is over, 0 1 is over. What is left now? 1 0. So I gave a value of 1 0. See here, you can see value of A is 1, and value of B is how much? Value of B is 0. Okay, 1 0 is also over. Then what is left? 1 is left. So I give a value of 1 here, and then I'll give a value of 1 here. This is also after having some delay. So whatever the thing I am writing here with respect to this hash 5, so this is known as what? This is known as some kind of time delay. Okay, this is known as a time delay. It means that initially at 0 time I gave a value of 0 comma 0 to variables a and b. Okay, I gave a value of 0 and 0 to the variables a and b, and then after waiting for 5 time units, after waiting for 5 time units, what is the value of ab I am giving? 0 1. After waiting for 5 more time units, after waiting for 5 more time units, what is the value of AB I gave? 1 0. And after waiting for 5 more time units, what is the value of AB I gave? 1 1. So I gave some random values in such a way that it covers all the different possible stimuli like 0 0 0 1 1 0 1 1. So okay, fine. Now let us give a stimuli a little bit more. Okay, hash 5 1100 okay, you can, as we have covered all the possible values, I can give any value here. Okay, and let me comment this line. Now we are done. Okay, so here what did we do? Here for the given AND gate we have covered all the possible scenarios of the inputs possible. So whatever the thing that you have written so far, it is known as, okay, input stimulus. What it is known as? It is known as a stimulus. Stimulus is nothing but the possible combination of inputs that needs to be driven to the DUT, or it is also known as input vector. Okay, whatever the values we gave here, they are known as what? They are known as input vectors. Okay, now so it is okay that I have given some values here, some so my design is ready, and I have coded my test bench also. I have coded my test bench with some possible values of the inputs. Okay, fine. And in line number 6 I have done something known as module instantiation. Now what I have to do? I have to run this code. Even before that, what I have to do? I have to save this code. So you could see here the star mark. What does the star mark indicating? It means that there is some unsaved code. So I have saved it. Okay, I'm clicking on save. Okay, now I have clicked on save. Okay, so before that, what you need to do is you have to select any one of the simulator. As the simulator is already selected, okay, so it has not popped up window basically. If you do not select any simulator, no. For example, let me write something here. I have written something and trying to click on save. So what it will show? It will show please select a valid tool or simulator. Okay, so in that case, what we have to do? We have to go to this particular window, tools and simulators, and click any one of the tool. For example, Simon's Quest. That's what I have done here. Okay, this is some dummy tab I have opened, and this is the actual tab where we are writing our code. So see here, here I have clicked on these tools and simulators. In it, there are few options. These are actually the tools that you guys were asking yesterday. These are the commercial simulator tools available in the industry that you can use for free, and its functionality is limited here as it is a free tool. And okay, so for time being I am selecting Simon's Quest, and I clicked on save. Now the code is saved. Now what I have to do? I have to run this code, but before running the code you have to select one option. You see here, what is the option you are seeing here? See here, what is the option you are seeing here? This is open EP wave after run. So what we need to do is we have to select this guy. Okay, we have to tick mark him. Okay, I am selecting this. Okay, I just selected this open EP wave after run. Okay, done. I have selected this. Now what I have to do? I have to save this code. I have to save this code. So I have saved it. Now I need to run. Now you will see one error. Okay, now you will see one error. See here, what is this error talking? What is this error telling us? It is telling that no VCD file found, or did you use dollar some nonsense came. So what you need to do? You just need to copy this as it is. You just copy this as it is and take one more initial block. Okay, take one more initial begin block, initial begin end block. You just paste it here and wait for something like 50 time units and then $finish. It means that you want to end your simulation. Okay, so now we are done with our basic coding here. So let me quickly recap on what we have done so far. Okay, so here what did I do? I have written code for my AND gate. So basically this is my DUT. This is the design. This is my core logic RTL design. In order to verify this design, what did I do? I have written a test bench for it. I have written a test bench for this. In the test bench, what did I do? I have declared my inputs as what? I have declared my inputs as registers, and I have declared my output as what? I have declared my output as wire. After that, what did I do? I have done something known as module instantiation. I have done something known as module instantiation. In this, what did I do? I have just copied the name as it is from here to here, and I just gave some instance name A1. Here you can give any name, A2, B2, C2, any name. So what is this A1 here? This is the module instance name. Then what did I do? I have taken one initial begin end block. I have taken one initial begin end block. In this initial begin end block, I have given the all the possible input vectors. Okay, all the possible input vectors, or I would call it as input stimuli, or in layman language you can call like all the possible input values like 0 0 0 1 1 0 1 1. So we have to write our input vector between this initial begin and end. Then what did I do? Okay, you have to select on which tool you have to run this, on which tool you want to run this. So I have selected any one of the tools, and then what you have to do? You go and select this option known as open EP wave after run, and then click on save. Click on save. Then click on run. If you click on run, you will see one error like did you use $dump something, you will get. You copy that error as it is, and you take one more initial begin end block. You just paste that error here. Okay, copy that here and paste it. That's it, as simple as that. Now what we need to do? Okay, see here, we need to save the code. You can see here I am saving, and then what I have to do? I have to run the code. I click on run. I click on run. Then the code will run. Now see here, the code was running and its corresponding waveform we are able to see. Okay, we are able to see its corresponding waveform. Before this, can you guys imagine like what could be the waveform for values of A and B? See, what is the initial value of A I gave? Initial value of A is how much? 0. So I gave initial value of A as 0. Then what did I do? After waiting for 5 time units, after 5 time units, what is the value of A again? It is still 0. So assume that this is 0 and 5. Okay, this is 0, 5, 10, 15, 20, 25. Okay. So see here, what is the initial value of A? It was 0. And what is the next initial value of A? It is also 0. Means for 0 to 5 time units, value of A is 0. And after 5 time units, what is the value of A? It is still 0. It will be 0 till 5 more time units. Means it is 0 for next 5 time units also. And then after that, see here, initially at 0 time units, value is 0. And after 5 time units, value is still 0. And after 5 more time units, 5 more time units means 5 time units is already over. Then it is, we are waiting for 5 more time units. Means totally how many time units? 10 time units. After 10 time units, what is the value of A? It is 1. Means after 10 time units, value of A become how much? It is 1. And again, after waiting for 5 more time units, what is the value of A here? It is still 1. So it will be 1 for next 5 time units. And then it is becoming 0 for later. I mean next 5 time units. So it is happening like this. Similarly, this is for A, right? Similarly for B, how does the waveform look? Initially, what is the value of B? It is 0. Okay. Initially, it is 0 and then it becomes 1. After how many time units? It becomes 1? 5 time units. So after 5 time units, it became 1. And it will be 1 and its value will change after 5 more time units. So it became how much? It became 0. And again, after 5 more time units, it became how much? It became 1. So it is going on something like this. The same behavior we can see in our EP waveform. So for this, can you guys guess the output? Okay. See, what is the functionality of AND gate? Y equal to A and B. Now, what is the value I am seeing here? 0, 0. Here it is 0, here it is 1. And here it is 1, here it is 0. Here it is 1. Here also it is 1. Here it is 0. And here some value, maybe 0. Now, tell me what is the 0 ANDed with 0 will be how much? 0, right? So here I will be getting 0. And 0 ANDed with 1 is how much? It is still 0. And 1 ANDed with 0 is how much? It is still 0. And then 1 ANDed with 1 is how much? 1. So here you can see the change in the output. And again the output will become 0. So it means that your output waveform will look something like this. So let us see the same thing with respect to our EP in our wave window here. Okay. See, I have opened the waveform. Here, please remember that you need not to see here. If you see A, B, Y and A, B, Y, you are seeing two set of inputs. You need not to focus on two set of these values. It is enough for you to see any one set. Either you analyze the top one or you analyze the bottom one. It is enough. So for the time being, I am analyzing the first one. Okay, A, B, Y. I am analyzing these three things. This A, B, Y. I am analyzing. I will be analyzing these things. Okay. So see here, basically here you got two set of outputs, two set of things in the waveform. It is because one is from the DUT and other one is from the test bench. Okay, other one is from the test bench. So let me place my marker here. Okay, I am placing my marker here. See here, you could see I have placed my marker here. And what are the values of A, B and Y it is showing? What are the values it is showing? See here, value of A is 0, value of B is 0, value of Y is 0. Now let me place my marker somewhere else, probably around here. So if I place my marker here, can you see the change of values in A, B, Y? See here, my A is 0, but what happened B? B become 1. So value of B has changed from 0 to 1. Value of B is changed from 0 to 1. That change of transition we can see here. Or let me place my cursor somewhere around here. Now here you could clearly see that value of B is transiting from 0 to 1. Yes, correct. Again, let me place my cursor here for time being. Here you see, okay, here you see what is happening. What is the value of A here? Until this time value of A is 0, but at 10 nanoseconds, what is happening to the value of B? It became 1. So my value of A is how much? 1. What about B? You could see here B is transiting from 1 to 0. The transition we can see here. So what is the value of B here? It is 0. That's what I could see here. And what is the value of phi? 0. So basically wherever you place your cursor there, you will be able to see its corresponding values. Okay. Now let us start analyzing our waveform on whether for the AND gate that we have designed, is it properly working? Is the functionality properly working or not? Let us verify that. A, B, Y 0, 0, 0, 1, 1, 0, 1, 1. So 0, 0, 0, 1. This is the expected functionality, right? Now let us verify the same. So you see here, okay, let me place my cursor somewhere around here. Okay, so what is the value of A here? Okay, what is the value of A here? 0. What is the value of B? 0. If my both A, B are 0, what is the expected output? Expected output should be 0. So that is the reason my Y is 0. So can I say that for the input 0, 0, the functionality is verified correctly? Because I could see here input is 0, 0 and I'm getting my output as 0. It is perfect. Next, see here at this point. So for the second instance, okay, for the second instance, where is the second instance happening? Can you see the timestamp here? See here, the timestamp is 5 nanoseconds. This is 0 nanoseconds. This is 10 nanoseconds. But here it is 5 nanoseconds. Why is the value of B changing at 5 nanoseconds only? See, because that is how you have written the code here. You see here, if you see here, initially the value of AB are 0, 0. Okay, fine. But after 5 time units, means after 5 nanoseconds, what is the value of A? 0. And what is the value of B? You made sure, you are the one who programmed it. You made sure that value of B is 1 here. So that is the same behavior we are able to see in the waveform also. Okay. So after some 5 nanoseconds, value of B is changing from 0 to 1. That behavior we could be observing here. Okay, we are able to observe here. Now see here, what is the value of A? 0. What is the value of B? 1. Value of A is 0, B is 1. So if your input is 0, 1, what is the expected output? 0. Am I getting that? Yeah, we could see here value of Y is still 0. Even though my input is 0, 1, my output is what here? It is 0. Means that, can I say that for the input 0, 1, my functionality is correct? Yes, I could say. Now, let us go to the third observation point. So see here, at 10 nanoseconds. See, here it is 10, and we could see the timestamp here. At 10 nanoseconds, what is the value of A? For time being, let me place the cursor a little forward. Like, at 11 nanoseconds, I'm placing the cursor. Please don't get confused. Okay, see here. At this instant, we could see that my value of A is transiting from 0 to 1, and value of B is transiting from 1 to 0. So what are the values of AB here? A is 1, B is 0. That's what we could see here. So if my input are 1, 0, then what is the output? 0. Is my Y 0? See here, my Y is still 0. So can I say that for this set 1, 0, my DUT is working perfectly? Yes, I could say. Now let us go to the next observation point. See here, let me place my cursor here. At 15 nanoseconds, okay, this is 10, this is 20, in between it is 15. At 15 nanoseconds, what is the value of AB? A is 1, that's what we could see here. And what is B? B is transiting from 0 to 1. So value of B is 1. If my input is 1, 1, then what is the expected output? My output should be 1. So that's what you could see here. The value of Y is transiting from 0 to 1 here. Okay. Let me place the cursor a little here. Then you would be able to observe it clearly. So see here. That's what we are able to see, right? My value of A is 1. My value of B is also 1. It is moving from 0 to 1 here. And then if both of them are 1, then what should be your output? See, this is my output. It should be 1. So that's what we could see here. It is transiting from 0 to 1. Okay. It is happening. So for inputs 1, 1, what is the expected output? 1. And am I getting that here? When I give 1, 1 as an input, am I getting 1 as output? Yes, I am getting that 1 as an output. So here, can I call that for all the possible input combinations, my device is working properly or not? Can I call it? Yes, because for every possible input combination, I have verified by using the waveform that it is working perfectly fine. It means that there is no any bug in the design. Okay, fine. So this is how you need to analyze your waveform. Everything in Verilog is with respect to waveforms, not just Verilog. I mean, everything in semiconductor industry, the verification is purely with respect to waveform. Okay, you will be able to justify whether what you are seeing is correct or not only with respect to the waveform. So that's what we have done here. We have done here the waveform analysis. Okay, and here for all the possible input combinations of our AND gate, we are seeing the appropriate correct results. Hence, can I call like my DUT is working fine? Yes, obviously I can call it. Okay. Now, see, let us go to the last observation point here. Okay, let me place the cursor here. So here what you see? What is the value of input? A is 0, B is 0. If both of them are 0, obviously output should be 0. That's what is the behavior we are seeing here. A is 0, B is 0, Y is 0. And this is at some 21 nanoseconds of timestamp. Okay, so this is how you need to work on this EDA playground. Okay, writing code is not important in Verilog. Analyzing the waveform is quite important. Anybody can write the code, but the one who analyzes the waveform with precision is a good engineer. Okay, any doubts here to anyone? Okay, okay, it's great, fine. So let us quickly go back to the code. Okay, see, look at the code again for a couple of minutes. Okay, now see here. I have told you, right, that if at all you want to use this EDA playground, you should have some official mail ID. Yeah, I have told you, if at all you want to use this, you should have some official domain name, domain-based mail ID. As I have some, my office-based office mail ID or some NIT Delhi mail ID, I'm using it. But you guys, all of you might not be having it. Then how will you proceed with this EDA playground? Hmm? How to proceed? I will tell you a method on which how you can proceed. See, basically what you need to do is, let me open something else. Okay, let me try to open. Okay, where is this? Another. Okay, yes. See here. So here, let me open EDA playground again. I have opened this EDA playground. Okay, now I do not have official mail ID here. Okay, see here, I do not have any official mail ID. Now what I'll be doing is, you just open your EDA playground just like that and write the code that you want. For example, here module ABC end module, and here initial, and I'll be writing something like this, dollar display. Okay, I'll write something like, hello. Done. I have written the code. Now what I will be doing is, I will be clicking on save. Then what it is telling, it is asking me to select a tool or the simulator. So go to the tools and simulators, select any one tool like Cadence, Zelium or whatsoever. Now save it again. I have saved it. Now run it. Now run it. Okay, run again. So it is asking me to validate. So you will not be able to validate. So there exists one option for you. See here, what you have to do is, you have to use any one of these free simulators. Okay, the difference between having your official mail ID and the normal mail ID is, if at all you have your official mail ID, you are entitled to use any of these commercial simulators, whatever the simulator you are seeing here, Synopsys, VCS, Siemens Questa, Cadence, Zelium, or Aldec Rivera Pro. So if you have your official mail ID, you are entitled to access this. As you do not have official mail IDs, you can normally log in with your Google account and choose these free simulators like, GHDL or iCaras Verilog. What I prefer is iCaras Verilog. So if you do not have your official mail ID, what I suggest you to use is this particular free simulator, that is iCaras Verilog. So now I'll select iCaras Verilog. As of now, you see I did not logged in, right? Now save the code and run the code. I am running the code. See here, I am able to see hello. It means that even by using your normal mail ID, you can be using this EDA playground. But the difference is that you are not entitled to use any of these commercial simulators. You are only supposed to use these free simulators, that is iCaras Verilog or GHDL. Okay. And coming to, yesterday many of you were asking me about like what are the tools available in the industry. See, these are the tools: Aldec Rivera Pro, Cadence, Zelium, Siemens Questa, Synopsys. These are what? These are simulators. These are the simulators. Is simulators alone enough in the industry? No, we need synthesis tools also. So what are the synthesis tools available? See here, Aldex synthesizer and Siemens precision. There are many synthesis tools, but these are few commercial synthesis tools available. And similarly, you can even use a free synthesizer like VLSI. VLSI is a free synthesizer which you can use if at all you want to do some kind of synthesis over here. So these are our industrial tools that are available for us, that are used most probably in our industry. So guys, this is how you have to play with your EDA playground. Okay, even though you have official melody, do not have official melody, you need not to panic. If you have your official melody, it is good. Why it is good? Because it supports enhanced features. If at all you use this, you will be entitled to use some typical coding. Even some complex coding can also be done. But these free simulators will not give you that greater flexibility. There is some limitations over it. And even these commercial simulators also will not give you the full flexibility, because as it is online, so even here it is, the scope is limited. Okay, so this is how you have to use, and these are the differences between having a official melody and accessing the tool, and normal melody and accessing the tool. Okay, so uh, apart from this, what you can do is you can simply search Google, like iCaras Verilog online. Okay, iCaras Verilog online. Some there are many intermediate guys who will provide you the simulator online. Okay, you can open any one thing, like for example, here I'll be opening something like you can open anything, circuit fever, HDL bits. Okay, here I'll open this. So it will, okay, or you better go with tutorials point. So it will open some window like this. In this you can write your code. Okay, whatever the code that I have written so far, you just you see here, I'll just copy it from here. Okay, and paste it here. But here both the code should be written in a single tab, and you just execute it. Okay, so you will be, but the problem here is you will not be able to see the waveform. Okay, the problem here is with the waveform. So that is kind of limitation, but you can have some display statements over here through which you can observe your outputs, if it is iCaras Verilog. I mean, but the best option available for you to do all these things is the EDA playground. You make a note of it, you bookmark this page, and whenever you have some free time, open this tool and do some basic level of coding. Okay, so you just follow the syntax that I gave you as it is. Okay, as of now, you should be least bothering on what is a module, what is an end module, and what is this assign keyword, why am I supposed to use, and what is this range, what is this wire. As of now, even if it is just our first day of coding, right? And even if I tell you, you will not be able to analyze it, you will not be able to understand it. But you just think like it's a prototype, and you have to do it as it is. You will know once you start the course, and once you start learning, you will realize like why it has to be done this way only. Is there any other way? For example, I have done module instantiation here. Is there any other way I can do this? Yeah, obviously. But as of now, I'm not teaching it, and you will know it at a later point of time. Okay, you just take this as your what do you say, a prototype, and on top of it you try to build everything. For example, you want to write code for a XOR gate or for an OR gate. What you will do? Simple, take this code as it is. You just need to keep a OR symbol here, y equal to a or b. Now what happens? The code becomes, see here, see the line number 6. I have removed the AND symbol and I kept OR symbol. Okay, anything need not to be changed, because even for OR gate, what is the input stimulus possible, guys? Okay, yeah, even for OR gate, what is the input stimulus possible? The same thing, right? A, B, Y, 0, 0, 0, 1, 1, 0, 1, 1. So what is the output here? It is 0, and for rest all the things it is 1, 1, 1, 1, 1. Okay, the only thing you need to do is change it to OR. If it is XOR, A XOR B. So like this, you can do all the basic logic gates implementation. So the talks that I am giving you for tomorrow is, you please use this tool and try to come up with code and analysis of all your basic logic gates. Okay, whatever the logic gates you have, like and or XOR, XNOR, NAND, NOR, buffer, all these things, you try to simulate this. Everything is same. Okay, everything is same. The only thing you need to change is this one particular line. Okay, you just need to change this one particular, take a snippet of this and you try to write the code, make sure that your code is error free, and right, just simulate it and try to analyze it using waveform. So let us quickly analyze on what is the output of the OR gate, whether is this working properly or not. Shall we do that? So save it.